I'm here to talk to you all about modern Swift app architecture, or rather a case study about it. My name is Simon. I work with Isotop. I'm an iOS developer with about 5 years in the field. I've been with the mobile apps team at Isotop since May of 2016. I'm a lover of all things Japan. Hit me up about it after the presentation. So, a little bit of background. Recently at Isotop, we overtook a new project. This project is an app for streaming radio and podcasts, and its existing code base is 100% Objective-C. So we thought this to be a great opportunity to try out a new app architecture in Swift. So the customer had some goals for us. First and foremost, they wanted to migrate to a new backend API. And second up, they wanted to introduce the ability in the app to play HLS streams, so HLS audio streams. And we had some goals ourselves. First and foremost, we wanted to write new features entirely in Swift. We also wanted to refactor older code piece by piece. We wanted to keep the number of third-party libraries low, and we didn't want to break anything, of course. So this presented us with a set of challenges. I'm going to take the time to talk about 3 of these today. The first one being introducing Swift piecemeal into our project. So this might be trickier than it seems. And the next one is integrating your new fancy Swift code with existing Objective-C. And then finally, I'm going to talk a bit about how we don't break anything. So let's start with the first one, introducing Swift piecemeal. And I'm going to start talking about networking, since that was one of the customer's goals. So a little bit of background about this. The backend uses a plain JSON REST API. And the existing code in Objective-C uses AF networking, which I'm sure a lot of you have come in contact with, as well as JSON model, which is a JSON deserialization API for Objective-C. And we wanted to be able to use Swift struct and codable protocols introduced in Swift 4. And also, we wanted to be able to migrate one endpoint at a time so that we didn't have to refactor whole huge swaths of code at the same time, so we could keep our pace high. So the solution we came up with to this is a networking API written in-house. It enables us to do this step-by-step migration that I talked about, so that we can migrate one step at a time. And it has an easy-to-use API, which makes it easier for junior and new project members to get started. And the first cornerstone of this API is this endpoint protocol. So this protocol basically describes an endpoint in the API. So you have the base URL where the host is located. You have a path to look up the HTTP method to perform. And it also declares some associated types in the form of a packer and unpacker, as we call them. These are used for either encoding the request body before sending it up to the API, or it decodes the response that you get back. I've left some things out for brevity, because it would be too much to list here. You pass endpoint instances to something we call a communicator. You see the perform request function in the bottom half of the view. It takes an endpoint and a completion handler. And so this completion handler, you can see the type alias at the top. It uses the Swift 5 result type that my colleague Veronica talked about earlier. And the thing you get back is the data type from the unpacker of the endpoint. So what this means is when you use this in your code, it looks a little bit like this. First up, you define your endpoint. In this case, I've defined a user endpoint, which is a get to the user endpoint on the back end, and it comes back with a user model. So to use it, I just give it to my communicator, and it returns the result, as you can see in the completion handler in the lower right, which I then can switch over, and in the case of a success, the response contains my user. So this makes it really easy to migrate our networking step by step. And next up, I'm going to talk a little bit about coordinators. So, background about coordinators. This project it makes really heavy use of back-end generated UI layout, which means that storyboards might be tricky to use. Also, I'm sure some of you have come in contact with this issue, especially when not using storyboards, that UI view controllers tend to get a lot of knowledge about each other, making it hard to decouple them. And we also had a wish that we wanted to try to minimize the use of singletons in the app for increased testability. So our solution to this is the coordinator pattern. There are some really great resources available, first and foremost from Saroush Khandu, who I think might have introduced the concept to the iOS community. And also Paul Hudson at Hacking with Swift has a really great tutorial on how to do some advanced things with coordinators. So for those of you who might not be aware of what coordinators do, here we have a really simple case of two view controllers. That the left one presents the right one, and this means that the left one has to know exactly how to set up and how to present the right view controller, making it tricky to remove the right view controller or change it into a Swift one that uses features that might not be available to Objective-C. So the coordinator slides in around here and removes the responsibility from the view controllers to know how to set up and present other view controllers. Here's a sample from our app. This is the coordinator protocol, or at least parts of it, that we use. We have defined the ability for coordinators to have children, meaning that it's easy to nest coordinators to make our navigation flow really powerful. We also have some useful utility extensions on the coordinator protocol for adding or removing children. And this makes us able to write code that looks a bit like this. So this is a login coordinator. It has a navigation controller that it pushes views onto, like this. And in this case, in the start function, we start a login view controller. And then in the show signup function, we show an Objective-C view controller from the legacy code. So this makes it possible for us to introduce Swift piece by piece without having to rewrite a lot of existing code. And this brings me into the second of our three challenges, and that is integrating Swift code with existing Objective-C. So I'm going to talk a little bit about something called the adapter pattern. As I'm sure many of you know, Objective-C can't use Swift struct and enum constructs. So that means if we write a Swift class that we want to use from Objective-C, we can't use any of those nice features. So how can we write a pure Swift feature while still maintaining Objective-C interoperability? And the answer is that we create adapters. So here I've defined a really simple class. It's an audio player that has a nested state enum. And this can't be used from Objective-C as is. But to enable Objective-C code to use this, all I have to do is this. Here, I've defined an NS-enum that Objective-C can see and use. And also, I've defined an audio player adapter class that wraps around the pure Swift player and maps its attributes and abilities to Objective-C compatible properties. And this allows me to have code like this. The Objective-C code is pure Objective-C, and it works with very little modification to the existing code base. My new code can be 100% pure Swift, which is really nice. And now moving on to the third challenge, how do we not break existing features? The answer to this for us was unit tests. Almost everyone talks about them, and everyone wants them. It can be challenging to get going sometimes, especially if you have legacy code that is intricately nested and hard to decouple, but they can really save your bacon sometimes. So our strategy to this was that when we were writing new Swift features that integrated with existing features, we were trying to cover the existing behavior with tests to ensure, first and foremost, that we understand what the existing code do. because it might be obvious to read it, but then it might behave differently, and there might be code paths that you haven't found. But it's important to try to add as little code as possible to enable testability, because otherwise you might spend a lot of time refactoring existing code, and that's time well spent making new features instead. And when making those new features, it's a very good idea to start with tests, especially when doing codable structs that I talked about earlier. Those unit tests can be quite tedious to write, a lot of boilerplate, but they can really be useful. And this can also be a great opportunity to try out test-driven development, which I can highly recommend. So for unit tests, especially for our networking models, we defined an extension to the XC test case class. We call it decode model. And as you can see, it takes in a verification block as its sole parameter, which in turn takes the generic model, which is an instance of decodable. And what this does is that it loads up a JSON file on disk with the same name as the model class, and then it tries to decode it, and then it passes it to the verification block, so that in my unit tests, I can simply focus on how the decoded model should look, which helps me to write small, effective, and fast unit tests, which might seem trivial, but this has saved us from quite some issues. And that concludes my 3 challenges. Quickly, a little bit about the patterns we try to use in this project. We aim to use model view, view model with coordinators, because it's a great pattern. You should check it out. We try to use dependency injection as often as we can. We also use repositories, promises, and functional reactive programming, whichever best fits the problem. And the result, after about 8 months of work, is this. We have about 40% Objective-C, about 40% Swift, and about 60% Objective-C after about 8 months of work. And this, without numbers of how many lines of code this is, might not be useful, but me, myself, I've removed about 100,000 lines of code and added about 80,000, so to give you a hint about the size of this project. And that means we're done with this presentation. Thank you. Any questions?
Hey, yeah, thanks for presentation. I actually had a question regarding your user endpoints.
Yes.
If you go back, maybe I can point there.
Yes,
so
sure.
The point was, for user endpoint, you have like one method which you kind of implement. But what if your endpoint has like post, delete, put, wherever methods? So do you need to create like different endpoints for each of them, or?
Yes, so the plan that we had was that you create a different struct or a different endpoint implementation for each of the different endpoints. So say, for example, we actually have the case where you might be able to, or where you are able to delete a user. So what we do then is usually we create a new struct that has delete, but also what you can do is you can put them in the same struct if you want to, I guess. We tried to keep them apart as much as possible.
Yeah, thanks. And another question is, you're testing your model kind of formatting or conversion, right? And how do you maintain API changes in that case? If you have like some local JSON files, do you just manually update them every time, or?
That's a very good question. We haven't encountered that yet. The API we've been working with has been strictly versioned. So that means that, as you could see in this slide, for example, it says /v2. So that means that the v2 version of the API does not change. And if it changes, then it's very, very small bug fixes usually. When we introduce a v3 API or another version of the backend API, of course, then we'd have to update the test as well.
All right. Third question, sorry. And you mentioned that you use dependency injection, but you never shown it.
Yes,
what framework, or do you have some in-house solution for that?
Actually, we do pretty straight up just define a protocol and pass it into the constructor of different classes and stuff.
Yeah,
so
thanks.
Hey, thanks. Good, really good presentation. I had a question regarding your packers and unpackers.
Yes.
You said in the beginning that you wanted to use codables and structs. Shouldn't they be pretty easy to code and encode, and what does the packer and unpacker do in this case?
Yes, you are right. They are very easy to decode and encode. The data packers and unpackers, right now what they do, we have a JSON unpacker and a JSON packer, which are concrete implementations of the two packer protocols. And basically what they do is they take the model that you pass into the endpoint or that you define in the endpoint, and then they basically just encode or decode them. But this allows us to have, for example, some models that are decoded using XML or decoded from XML and decoded to binary, for example, or something. So that was the reason why we chose to do or take that approach.
Hey, great talk. Thank you so much.
No problem.
I have a question. You mentioned that you use promises and reactive extensions.
Yes.
Do you use them in a single project? If so, what's your experience with using those two styles?
Yeah, great question. So actually we started out with reactive extensions, funnily enough. One might think that we start out with promises because one might consider reactive extensions to be sort of a superset of promises. Something that we've noticed is that reactive extensions, while being extremely powerful, and they allow us to do some really great things, especially when streaming audio, sometimes it's a bit too complicated, especially for newcomers. So then the promises that we've made, we've tried to create something ourselves because we use RX Swift for the reactive programming. Yeah, the promises are a bit easier to use for newcomers, basically. So that's it. We might reconsider having both of them available in the app and just go one way or another in the future.
First of all, thanks for great talk. My question is about the coordinator pattern. I was wondering if you ran into some things that don't quite fit into this pattern. Like one thing I might think about is maybe some complex custom presentations or, I don't know, maybe animations, things like that.
Yeah, another good question. So the good thing about coordinators is that they make it really easy to isolate custom presentation behavior. But a really definite downside of using them is that popping view controllers is a little bit more tricky. This is why we have the, let me see if I can show you real quick. We have it here, I guess. Yes, you see the remove child function here. As part of this process where we remove a coordinator child from another coordinator, we actually let it do some things by itself first and then call back to its parent when it's done. For example, if it needs to animate some view controllers going out of the view, for example, because that can be tricky, because the parent coordinator doesn't really know what the child coordinator has added to the stack, for example.
Hi, thank you first for the great presentation. We are using almost like the same patterns here, like MVVMC and coordinators especially. And we had a really big debate about whether we should use them from the view model or the view. Could you maybe tell us what you prefer to do? Because there's a debate on the internet about this, and it's not like there's a one-sided decision for now, at least from what I could find.
Yes, exactly. Yeah, that's you hit the issue there. Exactly right. It's really tricky. There's no really great way to do this. What we try to do is we try to cover the coordinator with a protocol, and then we try to pass it into the view model. And this makes it testable as part of the view model. So for example, if you make it part of the view, then, for example, button taps or other events that come from the view, they are passed straight to the coordinator. So they can't easily be unit tested. So if you want to make that easier, you can pass the coordinator into the view model, and then you can verify by, for example, creating a mock coordinator. You can verify that certain actions are called on the coordinator as part of the view model unit testing. But there's really no yes or no, this or that answer to this question, but that's what we usually try to do.
Yeah, I'd like to once again give a huge thanks to Simon and thanks to the audience for great questions.